The last session we have done with the first unit. Now today we are going to discuss second unit. The second unit about so these are the S silence. Second unit these are the following topics we are going to discuss. That is first one ubiquitous internet. Okay. Hello. Yeah. The first one ubiquitous internet. First, everyone, let me know that. Okay. Right. First one, can anyone tell me what are the deployment models? Cloud deployment models. Private, public, hybrid, right? Multi-cloud. So mostly three, and we have one more, multi-cloud. And we also have that service models. What are the service models? Okay, IaaS and PaaS and SaaS, and the last one is mainly three. Last one F, right? So who will maintain? Who will maintain all the services of a cloud? The cloud computing or cloud itself will have a different kind of resources. All the resources can be shareable, distributed, right? But there is a one authority is there to maintain all those services. That authority we call it as whoever is maintaining all the services in a distributed manner. Who will provide services? Service providers. The services are provided by the service providers, isn't it? Service providers. The service providers generally, what are the AWS, Cloud, Microsoft Azure, Oracle, IBM Cloud. So there are different kind of service providers are there, which are maintained by the different organization or a company, right? So now we are going to discuss about this ubiquitous internet, or we can say later we also compute ubiquitous computing also. This ubiquitous internet, what is normally internet? There is a connection, networks of connections, right? Physically, if in your lab, normally there are 60 desktops are arranged such that every system will get an internet connection. That connection may be sometimes a broadband network. There is a cable, local network cable is there. If you connect that only, the network will be, internet will be enabled. And sometimes it is Wi-Fi also. That Wi-Fi router is also connected through wire. Whenever we are using a Wi-Fi, the internet can be anywhere. The term ubiquitous meaning, general meaning of this is nothing but it can be available at anywhere. General meaning of ubiquitous is anywhere. Anywhere from the internet. So anywhere is can be possible. From anywhere I can access my mobile. From anywhere I can access my result. From anywhere I can watch movies by using so and so. Right? How it is possible to access a particular app from anywhere through the internet only. But how internet will be connected? Connected, and we are communicating with the remote system also. From anywhere, I will access my system, my desktop, which is at my home. Then that is called, there is a special software indicated VPN. But this will be happen, this communication will be happen. Babu, last. So this communication can be happened from anywhere. How this communication can take place? Communication can be established by using wireless, usually wireless communication network. The communication can be established wireless. We are not having any wire to your home to your place, but we can access it, right? So this ubiquitous internet refers to an environment where internet connectivity is available anywhere, anytime, and to anyone seamlessly. Yes, that's what we have mobile data. Wherever you go, if network is available, if your particular service providers will have a network, then definitely internet will be there in your mobile. Anywhere from internet, anywhere from your device, you can access all the things, whatever the apps you have. Normally, this computer it consists of basic diagram of this computer. As computer is a mathematical electronic device which can compute mathematical equations and complex problems can be solvable. Basically, computer consists of this memory unit and control unit, arithmetic logic unit, which are input and output devices for connected. Basic diagram. If we go with the internally what control unit contains, what arithmetic logic contains, we'll know that internal parts also. This represents basic diagram of the computer, whereas and these three terms: sense and process and result. Sense, process and result. Just to remember, we'll discuss these three in short period. Normally, ubiquitous internet is a ubiquitous internet. Anywhere you can access any application. Whereas the term ubiquitous computing, the term ubiquitous computing will be started from this person, and the scientist called Xerox Park. So he invented a word in ubiquitous computing. So he suggested in 1980 to 1990s a word ubiquitous computing will coming into the picture in future, and we can able to access those days during the period of 1988 99 1990 were accessing internet through wide connection only. Those days the wide connections only will access, and also systems can be mainframe computers were using a large system components we have. He suggested that he was given an idea in future we have a such type of computers. The computers are data or any information which is reside in your devices can be accessible from anywhere, right? So that is called ubiquitous computing. Ubiquitous internet to the word changes as ubiquitous computing. The term computing is nothing but the computer can process a data, right? For example, see this diagram. This is an at home. Normally nowadays, we're going to the shopping complex or any shopping malls. The door we should not open. Anybody will not open the door. When you are enter into in front of the door, with some specified distance, the door automatically opens. And metro trains also automatically open, automatically close doors. That will be how it will be happen. The automatic opening and door of close. There is normal door which is fitting. Yes, it looks like normal door only. Internally, it is embedded into a software by using different kind of devices. That's what we have a previously sense and input output. There is called sensors. By using, normally we can say that by using sensors only, the door will be open automatically, right? By using sensors, it will be opened automatically and without human being interference. See here, ubiquitous meaning is present anywhere and computing means it's computer or processing. So ubiquitous means is present anywhere in sense you will have a right to access at remote system data by using this computation method, ubiquitous computing method. For this ubiquitous computing method, but we need to install some softwares are embedding into the devices and also install a software from both the systems. In a single app, hey Babu, in single app we can control at our home we can switch on our fan. From here to at your home you can switch on your fan of so and so room. That the technology nowadays is available. If that is the technology comes under this ubiquitous computing, anywhere you no need to go to the particular switchboard of particular room. You can be anywhere at any time. You will have an operating, you have a control on the devices at your home. That is called smart devices we can say. Smart fan. Then with this fan is no need to switch on physically. You can have one app in your mobile and no need to present within the device, within the premises and outside the home also you can operate it. Right. You can open your door also. Automatic door also you can open it. Fridge automatically on it. So those are called as all the normal devices can be converting into a smart devices. So one person will use many computer. That is, one computer will use many computers in sense. Only the one person we have any different applications in your mobile, and you can operate at your home. Whatever the desktop is there, you can access the data. Will operate your uh, you can operate your washing machine. That is switch on, switch off. Lights switch on, switch off. Fans switch on, switch off. So different computing devices we can operate as a single user. And many embedded devices will form an ad hoc network or wireless LAN and communicate to provide different services. So this can be happen, I told you know, by having these are called embedded devices, sensors. We can embed it into the actually. This normal fan cannot work as a smart fan. To make it a smart fan, we need to add some devices or embedded some software into that. So there is a device called as embedded system chip is there. One chip we need to connect with this device, normal physical device. Later it will be coming, it will be converting into the smart fan. But what is there in that chip or embedded device? The chip or itself contain a set of instructions or we can say software that will be written by the developer and which can be have a linking to the app or application or website based on that instructions through internet. Everything is happened by through internet only. By having an internet connection, we can communicate with this device not from the same premises. You can communicate with the device from any distance. But these device and your mobile app should have an internet connectivity and should be paid already. These are smart enabled fans should only operate. సో నేను ఏం ఫ్యాన్ ఏం డివైస్ పెట్టకుండానే నాకు స్మార్ట్ ఫ్యాన్ కావాలంటే కుదరదు. Those are connected or communication between these device and app can be established between a wireless LAN. Normal LAN will have a local area not within the premises. Not within the premises. The word ubiquitous in the sense anywhere. మనం అంటాం కదా సర్వాంతర్యామి. The word Telugu meaning and sarvantaram. Ubiquitous mean anywhere in the geographical region. Ubiquitous. But what happened that nowadays sometimes this ubiquitous system in the real world it will not working properly because whenever we go into hill stations that are not enabled wireless LAN networks and it is not having internet connection. Due to that reason, when we are in the remote places which are not internet is not available, then we could not operate the smart devices at your home. And that is the drawback of this one. So this ubiquitous computing is called pervasive computing. Pervasive computing is nothing but we can compute, we can perform an actions or we can process the data. We can operate the device from anywhere, general meaning. So this smart device, I can open my my home main door without going to home. From here itself I can open my door. And also I can operate, switch on the LAN, switch on the light in the hall without entering into the home or without opening a main door, I can run a fan. So that is going to be happen because of the computing technology which we have an ubiquitous computing. Note down this definition is the most important. And but only to make it as a smart device of any physical device, some sensors are embedded into that. Embedding is nothing but attachment. So internal ga manam aa chip ni attach cheyali. So that's what ubiquitous computing devices such as sensors, smart appliances, variables and embedded systems continuously collect and data and exchange between the two devices or multiple devices. The last one, write down definition. Ubiquitous computing is a computing paradigm. Is a computing paradigm where computers where computers are embedded into where computers are embedded into everyday objects embedded into everyday objects and environments enabling them to operate enabling them to operate anywhere anywhere come all the time anywhere come all the time often without human interference without human interference without direct human interaction. So the next point says that to make a to perform to execute the instructions and ubiquitous computing we have an devices in ubiquitous computing the following devices are required. The devices such as sensors, smart appliances, variables, right? So see, this is a general idea how it is working. See, there is an environment wherever it is, local environment, not in a particular home, outside of the home. There are different devices. This is called one device, which is traffic light, which automatically give you a signal as a red signal, followed by orange, followed by green. Automatic traffic signal will be working by having an application called as ubiquitous computing. And whenever it is, this one is where is a vehicle it is going, and one person is crossing the road. Then this can be detected by the your CC camera. There is no person to shoot that situation. If anything is happened, we'll recall that CC footage, right? And there are these, it is identified by using a CCTV. So such that in the environment, not only the home appliances, right? So this is not for the home appliances. It is also for general environment, can be applied in ambiguous computing. See, I told you, these are the sense and process will be result. So these three will be affecting in a type of computing. To implement this computing, we need a smart objects. Normal fan cannot work as cannot be involved in the ubiquitous computing. Whenever it is converting it a smart fan. To convert that, we can convert every ordinary object. We can convert every ordinary object around like bulb, fan, motor, and everything into smart objective. We just need to integrate, we need to embed or integrate these. There is a sense, process, and finally will be result. The sense will be using the sensor devices, will be installed at a normal device, and also by using advanced electronic circuits. That's called as an embedding into a chip. The chip with a smart device, smart chip is there, which is code is or software is already embedded into. That small chip should be connected to the normal device with the sensors. Then this device will be converting into a smart device and also produce a result. The result may be always it is result may not be with the numbers or images. Sometimes electronic signals or mechanical physical values something. So it will be rotating. That is the result, right? It will not display any output. That is smart device output will not be same. Any smart devices output same gakapoch. So make a note that here the ubiquitous computing is working. Not on this how it is working. So if you are unable to see this, I will repeat this one. Write down to implement ubiquitous computing. To implement ubiquitous computing concept, to implement ubiquitous computing concept, don't make noise. Babu, itu. Ubiquitous computing concept, we need smart objects. We need smart objects. Write down. I request everyone note down. We need smart objects, comma. We can convert every ordinary object, every ordinary object around us, every ordinary object around us, in bracket, like fan, bulb, any home appliances, fan comma, bulb comma, and so on, any home appliances, bracket close, ordinary objects around us, into a smart objects, into a smart object. To do this, we need to integrate. To do this, we need to integrate these three properties. We need to integrate these three properties into ordinary or normal object. Into ordinary object. First one, sense. That is by using sensor devices, it can be integrated. The first one is sense is one property. So smart devices will have these properties. It have a sense property and it has a processor and it has a producing a result capability. Sense property will be integrated by installing by using sensor devices. And second property that process. It will process the information or user instruction. How? The process by using advanced electronic circuit. In bracket write down chips. Process by using advanced electronic circuit bracket write down chip. CHIP. Last one result. Results may be in electronics. Result may be in electronic form or in a mechanical form. Results may be in a electronic form or mechanical form by using actuators. Actuator is a device which produces the result of smart devices, which displays the result. Mechanical form by use of actuators. But every time, wherever you have a smart device, should take care of the device. When you are a mobile is a smart device, should be take care about this. That's what we are by caring of this mobile only. We have first of all we are having a this screen guard. We are protecting our to protect our screen. We are ensuring and we are having a screen guard. And also that this case, body case also we are wearing. For all these are because of to protect that smart device, isn't it? Whenever in the same way, if your home appliances are smart devices, it becomes smart devices. Definitely, you have some challenges, some problems. You need to take care about that because of the smart fan is there. To avoid this fault tolerance, we should take care about this one. The challenge may be a security problem. See here, protecting ubiquitous devices and network from unauthorized access and cyber attack is difficult. అందుకే నార్మల్ ఏసీ ఉంటుంది మీకు ఎంఐ మొబైల్ డూ హ్యావ్ ఎంఐ మొబైల్ ఇఫ్ యూ హ్యావ్ అన్ ఏసీ ఇయర్ normally AC can be operated with a separate remote. If remote is not there, we cannot able to operate. That is general process. If remote is not there, we are unable to operate that AC usually. But there is a smart device, MI mobile phone will have an app called as remote app. That remote app will provide that you can operate your device, which is a AC condition of anywhere, which is this AC is not related to you because this is an artificial AC. If it is there, then that can be operated actually in the remote system. That remote is not there, and you are no way concerned about this device AC, but you have a smartphone, MI phone. There is an option that MI you can operate it. Then what happens? The management is actually it is not switched on. For example, device which is not switched on due to various reasons, but you have done that operating. You are switched on. You means it is an unauthorized person. It is unauthorized person. That may be a problem in smart devices. So to make sure that that type of smart devices. ఇక్కడి నుంచి రావట్లేదు. So the smart devices, actually we should do that. The management has to be disabled to work except or remote only. With all the smart devices cannot be work. ఆ ప్రొసీజర్ చేయలేమనుకోండి, ఎవరైనా ఏసీని ఆన్ చేయొచ్చు, ఆఫ్ చేయొచ్చు, అండ్ యూ కెన్ ఇంక్రీజ్ అండ్ డిక్రీజ్ ద టెంపరేచర్ ఆల్సో. దట్ లీడ్స్ టు డ్యామేజ్ ఆఫ్ ఏ స్మార్ట్ డివైస్. నీ ఇంట్లో స్మార్ట్ ఓపెనింగ్ సిస్టమ్ స్మార్ట్ లాక్ ఉంది, దాన్ని ఎవరైనా ఓపెన్ చేయొచ్చు అని అనుకోండి, ఎవరైనా, దట్ ఈస్ కాల్డ్ హ్యాకింగ్. Because of that, hacking can be done with a poor quality of security reasons. The privacy may not be controlled. You have done simple encryption and decryption algorithms, it may be hacked. So for smart devices, there may be a challenge to protect from the unauthorized user. That should be taken care by the actual users by providing high-end security and like privacy also. So continuous data collection can expose users' personal and sensitive information. Definitely, a smart device is when you are operating, either you opening and closing or switch on and off, that communication can be established. Communication, once communication is established, definitely data will be stored in somewhere else. The data should be have a personal information regarding to your home. That should be maintained personal as. I mean, class అంటే ఎగ్జామ్ పెట్టేద్దామని. Exam. If you are not interested to listen, we'll have some exam. What we have covered yesterday, I told you already. If I thought to complete this one, then later we'll discuss about the test. If you are not able to interest, then we'll go with the test. You write a test again. If start exam, you are interested to write. So mostly this will be finishing daily, second in it. So here the smart devices will be provided privacy because definitely smart devices operation can exchange the information. That information exchange can be done through the server only. The server should have a privacy of respective users. And the next one is data management. Handling and storing, processing large volume of real-time data is complex. So this data management is a one more challenge because every time we are switch on, switch off, and every time we are switch on AC, switch on the fan, and opening the door or closing the door, the data may be huge amount of data will be generated. That should be maintained. To maintain the data management, huge amount of data should have a large storage system. That also the one most best challenge. And interoperability, different devices, right? Interoperability is nothing but we have communicating with the different devices. That pairing of different devices should be responsible for the user. అంటే మనకు స్మార్ట్ ఫోన్ ఉంది, ఈ స్మార్ట్ ఫోన్ నుంచి నేను ఫ్యాన్ కనెక్ట్ చేయాలి. Basically these two are the two different devices. But we should communicate with smart device with a normal device. That communication can take place by integrating some three properties into normal device, then it becomes smart device, and the connection should be established. This is called interoperability. So the communication can be established between two or more different devices. Little complex to establish a connection is one of the challenge. And also scalability. Scalability is a one more challenge. The supporting growing number of devices without performance degradation is challenging. If data storage is limited storage, you are maintaining a limited storage data and generating data is huge amount of data is generating, then we can accommodate, we are not able to accommodate in that occupied space. Then every time you are switch on, switch off, the data will be generated. So once the data storage is full, Next time we cannot able to operate. Next time we cannot be able to operate because of scalability. Scalability says that when a huge amount of data is there, then automatically the limited space, it should not be limited, the space should be increased automatically. It should be scaled according to the input data. And reliability. Reliability says that we are expecting from the smart device uninterrupted services. The long lasting of smart device we are expecting. సో ఫస్ట్ డే ఒక రోజే స్మార్ట్ డివైస్ ఫ్యాన్ వేసి స్విచ్ ఆన్ చేస్తే రిమోట్ ప్లేస్ నుంచి యాక్సెస్ అవ్వాలి, మళ్ళీ ఓపెన్ అవ్వాలి, డోర్ క్లోజ్ అవ్వాలి, అండ్ 2 days తర్వాత వర్క్ చేయలేదనుకో, దెన్ వీ కెన్ సే దట్ దట్ సిస్టమ్ ఈజ్ నాట్ రిలయబుల్. సో రిలయబిలిటీ షుడ్ ఆల్సో యాజ్ వన్ ఆఫ్ ద ఛాలెంజ్. రిలయబిలిటీ అంటే మనకి ఇన్ ద మార్కెట్ దెర్ ఈస్ ఎ డివైస్ అవైలబుల్, మస్కిటో బ్యాట్. మస్కిటో బ్యాట్స్ ఉంటాయా? నార్మల్లీ మనం బై చేసేటప్పుడు చెప్తారు వాళ్ళు, దిస్ ఇస్ ద బ్యాట్ విచ్ విల్ వర్కింగ్ ఇయర్, సీ దిస్ ఇట్ ఈస్ వర్కింగ్ నౌ. మీరు ఇంటికి వెళ్ళాక వర్క్ చేయకపోతే మాకు సంబంధం లేదు. దట్ ఇస్ నో రీప్లేస్మెంట్ ఆఫ్ దిస్ ఐటమ్. మీన్స్ దట్ ఫర్ సచ్ టైప్ ఆఫ్ ఐటమ్ దే ఆర్ నాట్ ప్రొవైడింగ్ ద రిలయబిలిటీ. సమ్ టైమ్స్ సేమ్ షాప్లోనే ఇంతకుముందు సేమ్ ఐటమ్ తీసుకున్నాం విచ్ ఈస్ 3 months వర్క్ చేసింది, అండ్ నెక్స్ట్ మళ్ళీ సేమ్ ఐటమ్ సేమ్ కంపెనీ సో అండ్ సో సేమ్ షాప్లోనే తీసుకున్నాం, ఇమీడియట్గా 1 day ఫెయిల్ అయిపోయింది ఐటమ్. So then we can say that that company of a product does not maintaining a reliability. అక్కడ ఎక్కడ ఎన్ని రోజులు వర్క్ చేస్తో చెప్పలేము. బట్ హియర్ స్మార్ట్ డివైజెస్ వీ కెన్ ఎన్ష్యూర్ దట్ రిలయబిలిటీ షుడ్ బి దేర్. ఆ రిలయబిలిటీ ఉండాలి. రిలయబిలిటీ ఉండాలంటే ఎవ్రీ ఐటమ్ ఆఫ్ ద సేమ్ ప్రోడక్ట్ కరెక్ట్గా పనిచేయాలి. మార్నింగ్ లాక్ ఓపెన్ అవుతుంది, ఈవినింగ్ ఓపెన్ కాలేదనుకోండి, అండ్ నెక్స్ట్ డే మళ్ళీ వర్క్ చేస్తుంది, రైట్? సమ్ టైమ్స్ మన మొబైల్ కూడా ఒక్కొక్క స్మార్ట్ డివైజెస్ దెర్ ఇస్ గెట్ ఏ ప్రాబ్లమ్. ఒక్కోసారి ఆటోమేటిక్గా మనకు తెలియకుండా లాక్ ఓపెన్ అయిపోతుంది, కాల్ పోతుంది. ఒకసారి లాక్ ఓపెన్ చేసినా ఓపెన్ అవ్వదు. దట్ ఈస్ కాల్డ్ inefficiency of reliability. But such a devices we cannot tolerate and we cannot consider into the matter. Then so every smart devices should be maintain reliability such that there is a one challenge of the developers. And energy consumption also, definitely the sensors work చేయాలంటే పవర్ ఉండాలి, సమ్ ఎనర్జీ కావాలి. సో ఎనర్జీ అంటే పవర్ కనెక్షన్ ఇవ్వాల్సిన అవసరం లేదు. స్మార్ట్ డివైజెస్ అన్నిటికీ స్మార్ట్ డివైజెస్కి ఆటోమేటిక్ డోర్కి పవర్ ఉన్నా లేకున్నా ఆ డోర్ ఓపెన్ అవ్వాలి, క్లోజ్ అవ్వాలి. ఇంటర్నల్లీ దేర్ ఇస్ షుడ్ బి ఎన్ ఎనర్జీ, ఎలక్ట్రికల్ ఎనర్జీ దేర్. ఫ్రమ్ దట్ ఎనర్జీ కన్జంప్షన్ యాజ్ లిటిల్ యాజ్ వీఆర్ ఎక్స్పెక్టింగ్, అంటే తక్కువ ఎనర్జీ కన్జంప్షన్లోనే మనం ఈజీగా వర్క్ చేయాలి. అదర్వైజ్ ఇట్ టేక్స్ సమ్ కాస్ట్ ఫ్యాక్టర్. సో స్మార్ట్ డివైజెస్ షుడ్ బి developed in such a way that energy consumption should be minimal, as minimal as. Many devices have limited battery power and must operate efficiently. అంతే కదా, చాలా తక్కువ పవర్లోనే అయిపోవాలి. అంతేగా మనకి ఇప్పుడు లైక్ లైక్ ఇయర్ లైక్ యువర్ మస్కిటో బ్యాట్ ఛార్జింగ్ ఎంత పవర్ పడుతుంది? వెరీ లిటిల్ అమౌంట్ ఆఫ్ పవర్ కన్సంప్షన్ విల్ బి టేకెన్. అంతేగాని వన్ వన్స్ ఇఫ్ ఇట్ ఈస్ డిశ్చార్జ్ యువర్ బ్యాట్, ఒక్కసారి డిశ్చార్జ్ అయిపోతే ఛార్జ్ అవ్వడానికి 2 units కన్సంప్షన్ చేసింది అనుకోండి, 2 units ఆఫ్ ఎలక్ట్రికల్ పవర్ కన్సంప్షన్ చేసింది అనుకోండి, దెన్ విల్ గెట్ కరెంట్ బిల్ యాజ్ మోర్. అంతే కదా, ఎక్కువ కన్సూమ్. సో కరెంట్ బిల్ మోర్ అంటే వచ్చే దానికన్నా దాని యూజ్ కన్నా కరెంట్ బిల్ ఎక్కువ పే చేయాల్సి వస్తుంది. సో దట్ ఈస్ నాట్ యాక్సెప్టబుల్. దెన్ సచ్ టైప్ ఆఫ్ డివైజెస్ విల్ నాట్ బి will not be exist in the market. That is energy consumption. Cost also. You can design, you can convert a normal or ordinary device into a smart device, but conversion process should take minimal cost only. Smart devices, mere IoT applications ఎప్పుడైనా చేశారా? IoT projects. Normally, these smart devices can be converting ordinary into a smart devices. Very simple process. IoT projects can do nowadays. These school children also they are doing an IoT projects. Automatic sensors లో door open కావాలి door close కావాలి. They will use the simple instructions and simple material, two batteries, one sensor and different items with a minimal cost only they can do. So such that we are expecting to convert a normal device into a smart device with minimal cost only. అంతేగాని any స్మార్ట్ డివైస్ స్మార్ట్ డోర్ పెట్టుకోవాలి స్మార్ట్ డివైస్ కన్వర్ట్ చేయాలి 1 lakh రూపీస్ అయితే అంటే ఎవరు అవసరం లేదు. So we can make sure that that is also one challenge while it is converting a item, normally item into a smart item. So these are the applications of, note down applications of ubiquitous computing. Applications of ubiquitous computing. First one, personal identification and authentication. Personal identification and authentication. Personal identification and authentication. So this is a one smart device. మనం ఆఫీస్ లో జస్ట్ లాగిన్ సేమ్ అటెండెన్స్ కోసం వెళ్ళి ఫేషియల్ రికగ్నిషన్ ఉంటుంది. ఫేషియల్ రికగ్నైజేషన్ అండ్ ఫేషియల్ రికగ్నిషన్ డివైస్ ముందు వెళ్ళి నిల్చొని జస్ట్ ఇట్ విల్ స్కాన్ యువర్ ఐస్, then it will be given you have logged in so and so your name, రైట్. మన ఎంప్లాయీస్ అందరికీ స్మార్ట్ డివైజెస్ పెట్టేసి జస్ట్ లాగిన్ దగ్గరికి వెళ్ళిపోయి ఈ ఐస్ పెడితే అయిపోయింది. ఐరిస్తో లాగిన్ అవ్వచ్చు. ఎవరు ఎప్పుడు వచ్చారు అనేది ఎక్సెల్ షీట్లో జనరేట్ అయిపోయింది. హెల్త్ కేర్ సిస్టంలో, హెల్త్ కేర్ సిస్టమ్ ఆల్సో దెర్ ఆర్ సో మెనీ స్మార్ట్ డివైజెస్ వీ హ్యావ్. టెంపరేచర్ ఎలా చెక్ చేస్తారమ్మా డాక్టర్? టెంపరేచర్ which device it is using for temperature? Temperature is checking with normal doctor. Thermometer. Thermometer పెట్టుకోవాలి, టెంపరేచర్ అక్కడ వస్తుంది. But nowadays it is no need to have a thermometer. There is a one smart device which one light will be focusing on your head, then immediately displays your temperature. Thermometer is not to hold it in your mouth at 1 second, 50 seconds or 30 seconds. That is gone. Now temperature can be identified with only them. Pulse rate, heartbeat, heartbeat ఇట్లా పెట్టి చూడాల్సిన అవసరం లేదు. There is a device, everything will be available. A smart device and portable devices. షుగర్ టెస్ట్ ఏంటి? షుగర్ టెస్ట్ తెలుసా? డయాగ్నోస్టిక్ సెంటర్కి వెళ్ళాలి, బిఫోర్ మీల్ ఆఫ్టర్ మీల్ బ్లడ్ శాంపుల్ కట్ చేయాలి, తీయాలి. దెన్ వుడ్ హ్యావ్ టు వెయిట్ 1-2 hours, then you will get a one report. Nowadays no need of that. At your home only you can do sugar test. There is a device available with some card and make it into the, take a blood sample drop, one drop, immediately it displays your sugar values. A physical copy experiment lab అవసరం లేదు. Those are called ubiquitous computing technologies integrated into that device. There this is an use. Healthcare system, transport system. Transport lo kuda same. Ubiquitous automatic door open close, right? And home automation like we discussed, defense industry and industrial production and material management. These are the cases where we are going to apply ubiquitous computing. Next one, healthcare. Write down transport system, home automation, defense industry, industrial production and material management. Right? This is about ubiquitous computing. Next, we are going to discuss about actually distributed computing. Before going to distribute, you should have an idea about serial computing. Serial computing is nothing but serial evaluation. Serial is nothing but one by one, one by one. There is a one processor. There is only one processor. This processor will do all the activities, all the actions, all the tasks, all the jobs. The tasks or a problem or a process can be divided into number of instructions. And ఒక వర్క్ number of instructions are divided అయిపోయి ఆ వర్క్ అంతా చేయాల్సింది ఒకటే. That is called processor. And this processor will have to execute all the things. For example, task 1, task 2, task 3. All these tasks should be executed by this one person only called as processor. But if you take in order, first go with the task 1, next task 2 or 3, or else whatever you order it is given. For example, give an order as task 1 first. Again the task 1 also can be divided into number of subtasks for easier. First subtask, second subtask, third subtask will be executed in a serial manner. That is called serial computing. So traditionally software has been written in serial computation to be run on a single computer having single central processor unit, one processor. The problem is broken into discrete series of function. One problem can be divided into different number of subproblems. Instructions are executed one after the other. Only one instruction may be executed at one time. For example, in a switch case C program you have written, when I have given an option that one, it will be produce a result addition of two numbers. When I have given a instruction or number sequence switch number choice is 2 and it should perform multiplication. If my choice is 3, division it should perform, right? For that program the instruction will be executed in a sequence manner based upon your choice. Based upon your choice that program will be executed. First case is set of instructions addition of two numbers. Multiplication of two numbers. Next, division of two numbers. That complete task can be divided into parts case by case, and each time the case is executed one by one. So that is all these cases should be run in a one single process. The processor is only one CPU. You have to execute all the instructions. ఆ ఇన్స్ట్రక్షన్స్ కూడా మళ్ళీ సబ్ పార్ట్స్ గా డివైడ్ అయిపోతాయి. ఇంకా ఫంక్షన్ ప్రోగ్రామ్ లో రైట్ ఏదైనా ఫంక్షన్ 1 ఫంక్షన్ 2 ఫంక్షన్ 3 ఎందుకు 1 2 3 ఫంక్షన్స్ ఎగ్జిక్యూట్ చేస్తాం. సో ఎంటైర్ ప్రోగ్రామ్ 100 లైన్స్ ఆఫ్ కోడ్ రాసే వాళ్ళు రైటింగ్ 100 లైన్స్ ఆఫ్ కోడ్ 1000 లైన్స్ ఆఫ్ కోడ్ parts. Each part I can say it is a one function. Function 1 is purpose 1, function 2 purpose 2, function 3 purpose 3. All these functions will executed, then actual task will be closed. So first function 1 execute avali, that is only 50 lines of code. Function 2 70 lines, function 3 30 lines. Such that entire instead of writing 200 and 150 lines of code can be categorized as three parts, 30 lines, 50 lines, 70 lines. Then instead of executing 1000 lines at the same time, 30 lines is easy. Easy to understand even. Easy to understand also. Instruction ఒక్కటే execute చేయాలి processor. And same processor again you go with the second 70 instructions could be executed. Next one more third part also can be executed. Always this processor is same but the number of tasks are different. That is serial processing. ఒకదాని తర్వాత ఒకటి అయితే serial processing. Note on this one everyone. Note on this serial processing. Serial processing or serial computing. It will run on single computer. It will run on single computer having single central processing unit, having single CPU. Problem is broken series of The last point, only one instruction may execute at any moment. One instruction may execute at any moment. Only one problem is only one problem. That problem can be divided into number of tasks, and each task will be executed by the same processor. Processor is same. T1 will be done the processor. T2 also, T3, T4 and Tn. All the subproblems can be executed by the single processor. Better note on this diagram. Once you can see this one, single computing, single processing can be executed. Single processor can be executed by all the tasks. That is called serial computing, serial processing. Note down this one. Right. Next one, computing. The next one, parallel computing. From the name itself, we can say that parallel computing. Serial and parallel. Parallel is nothing but more than one at the same time. More than one, not only task one. Task one and task two at the same time, there is parallel processing. Babu, parallel processing ante, serial processing ante, task one, next task two, next task three, next task four. One by one. Parallel processing in the sense, task one, same time, along with this task one, task two. Along with this, task three also, task four also. Multiple tasks will be executed at the same time. See, parallel computing is a form of computation which many calculations are carried out simultaneously. Many number of tasks, many number of applications can be run simultaneously. So it is simultaneous use of multiple computer resources solve a computational problem. See, once it is before going to this, see this diagram. So here, this is the actual problem can be divided into n number of problems. Problem 1, problem 2, problem 3, problem 4. So here, this problem 1 and problem 2 will execute the same time. This is a problem 1, problem 3, problem. So first problem, second problem, third problem will be started execution at the same time. At 10 o'clock, T1 started. Same 10 o'clock, T2 also started. 3 also started. So note down these points. In the parallel computing, more than work can be done. More than one work, not only work 1, work 2, work 3 can be done at the same time. అంటే 3 processors ఉండాలి. Can be executed by the processor. ఇక్కడ ఏం చెప్తున్నాం? Every processor will be executed instruction at one time, one instructions only. బట్ ఏమనుకున్నాం, ఇన్స్ట్రక్షన్ 1, ఇన్స్ట్రక్షన్ 2 రెండు ఒకేసారి కావాలి. రెండు ఒకేసారి కావాలంటే 2 ప్రాసెసర్స్ కావాలి. రైట్. ఇద్దరు సేమ్ టైంలో వర్క్ అవ్వాలంటే there are two members can travel from here to there అంటే there are two separate routes, there are two vehicles. So that shows that multiple processes. In the parallel computing, there exist multiple processes. In the previous case, serial processing, serial computing will have a single processor, one CPU only. మళ్ళీ ఇక్కడ వన్ సిపియు అంటే ఆల్వేస్ మన సిస్టమ్స్లో ఒకటే సిపియు ఉంటుంది కదా, ప్యారలల్ ప్రాసెసింగ్ ఆ సీరియల్ ప్రాసెసింగ్ అంటే నౌ డేస్ వీఆర్ యూజింగ్ ప్యారలల్ కంప్యూటింగ్ బికాస్ the processor, what we call processors, my processor is dual core, octa core, hexa core. The core is nothing but a processor. Dual core, two processors. Octa core, octa ante eight, eight internal processors are there. Task 1, task 2, task 3, task 4. Because there are 8 processes. 4 processes can be done at the same time. 4 tasks can be done executed at the same time. Because we have a more than one processors. That is called parallel computing. Okate processor, single core processor. So that's what we can do in our system while we are playing a music. We can prepare a Word document. We can prepare a Word document and one window. In one window, we'll play the songs. And one more window, we can open a Google Chrome, we'll surf the internet. అన్ని మల్టిపుల్ టాస్క్ చేయొచ్చు కదా, సాంగ్స్ ప్లే అవుతూనే ఉంటాయి. వాట్సాప్ వాట్సాప్ కూడా ఓపెన్ చేసుకో, సపరేట్ చాట్ చేస్తూనే ఉండొచ్చు. అండ్ పక్కన డాక్యుమెంట్ ప్రిపేర్ చేసుకుంటూనే ఉండొచ్చు, పక్కన పీడిఎఫ్ ఉంటే చదవచ్చు. ఆల్ దీస్ వర్క్స్ ఆర్ డన్ simultaneously, not simultaneously, at the same time. That is called parallel computing. Instruction from each part execute simultaneously on a different CPU. CPU 1, CPU 2. CPU is nothing but here, assume that processor. CPU ante a box mottam CPU kaadu. We don't have any separate box for the one. Processor, we can say it here CPU. So octa core is a multiple processors it contain. In that all the instructions will be executed at the same simultaneously. And this is a diagram for the parallel computing. The problem can be divided into 1, 2, 3, 4 problems or 5 problems, and each problem can be executed at the same time by the different processors. Processor 1, 2, 3, 4 processors. 4 processor will be executed at the same time, 4 instructions. T1, one processor, T2, one processor, T3, one processor, T4, one more processor. నలుగురు ఉన్నారు కాబట్టి 4 వర్క్స్ చేసేయచ్చు ఈజీగా. As compared to the serial processing or serial computing, parallel computing is more efficient and it takes less amount of time to complete a task. ఇక్కడ ఉన్న చైర్స్ అన్ని బయట పెట్టాలనుకో, we have assigned that work to only one person. These 100 chairs should keep outside అని ఒకటి చెప్పినామనుకో, one by one, one by one, one by one. 15 minutes. 15-20 minutes పడుతుండొచ్చు one chair బయట పెట్టాలి. The same task is assigned for the 10 members. 10 members. Each time 10 members ఒకటేసారి 5 chairs బయటికి వెళ్ళిపోతాయి. 10 chairs will be kept outside. Next again 10 more, 10 more. So instead of having a work at 15-20 minutes, it may be finished in the 5 minutes or 10 minutes. Less time. That is called multiple process. ఒక్కరు చేయాల్సింది ఇక్కడ మల్టిపుల్ యూజర్స్ ప్యారలల్గా అందరూ సేమ్. So we are using a parallel computing. The main reason ఏంటి ఇందాక ఈ 100 చేసి ఒక్క పర్సనే బయట పెడితే ఇట్ టేక్స్ మోర్ అమౌంట్ ఆఫ్ టైం and more space. For example, faster execution, isn't it? 20 minutes అయ్యే వరకు we are expecting that work is 10 minutes only. Faster execution, high performance, multiple processor work together to handle complex problems efficiently. ఒకే పర్సన్ ఈ 100 చేసి బయట పెడితే ఈమె టైడ్ అవ్వచ్చు, ఒక పర్సన్ అన్ని చైర్లు మోయాలంటే. అదే 10 మెంబర్స్ అనుకోండి, there is no chance to tide. For 10 members easy work, they will now be strain అవ్వకపోవచ్చు. 10 members 100 చేసి పెట్టడం, that is like then definitely they will work efficiently. Scalability, performance can be increased by adding more processors or core. Performance is nothing but how effective will be done. So ఒక్కరు చేసేదానికన్నా 10 మంది చేస్తే ఈజీ అయిపోతుంది వర్క్. Right? So here high performance, the performance multiple processors work together to handle complex problems efficiently. ఒకరే చేస్తే that be burden on a one person. That burden can be shareable. So nobody can strain more. Now done, these are the reasons for parallel computing. So that's what nowadays we're using an operating, our operating system supports multiple processor system. Multi-processor system, that is octa-core dual core. First one is write down faster execution, high performance and scalability. Note down everyone. Faster execution, reducing overall computation time. Simultaneously reducing overall computation time. Next one, multiple processors work together. Increased by adding more processors or cores. Core is nothing but processor. Dual core, octa core. Right? The next one, the next reason, continuation. Efficient resource utilization. Efficient resource utilization. Efficient resource utilization అంటే we have a different kind of resources. అన్ని యూజ్ చేసుకోవాలి. ఇక్కడ 100 మెంబర్స్ ఉన్నారు. 100 మెంబర్స్ని యూజ్ చేసుకుని ఒకరికే ఇవన్నీ చేసి బయట పెట్టే కన్నా వీల్ హ్యావ్ ఏ ఆల్ మెంబర్స్ టుగెదర్ వీల్ హ్యావ్ ఎ వర్క్ దట్ ఎవరి వన్ కీప్ వన్ షేర్ అవుట్ సైడ్ ఈజీలీ. అంతే కదా, అంటే అందరినీ యూజ్ చేసుకుంటే ఈజీ అయిపోతుంది. ఇన్ ద సిస్టమ్ టు కంప్యూట్ టు ప్రాసెస్ ఎ డేటా ఆల్ ద రీసోర్సెస్ దట్ ఈస్ ప్రాసెసర్ 1 2 3 4 ఆర్ దేర్. ఒకటే ప్రాసెసర్ రన్ చేసే కన్నా యూ కెన్ రన్ మల్టిపుల్ ప్రాసెసర్స్. నువ్వు సిస్టంలో యూట్యూబ్ చూసేటప్పుడు నెక్స్ట్ యూ వాంట్ టు ప్రిపేర్ ఏ వన్ డాక్యుమెంట్, రైట్, వర్డ్ డాక్యుమెంట్ కూడా యూజ్ చేసుకోవాలి. నా యూట్యూబ్లో సాంగ్స్ విన్నా దీంట్లో కూడా వినాలి. అంతేగాని నేను సాంగ్స్ వినేటప్పుడు వర్క్ చేయొద్దు, వర్క్ చేసేటప్పుడు వాట్సాప్ చాట్ చేయొద్దు అండ్ నెట్ సర్వ్ చేయొద్దు, ఏదో ఒకటే చేస్తామంటే ఇట్ ఈస్ వెరీ కాంప్లెక్స్. కాంప్లెక్స్ ఇస్ అ టైమ్ కన్సంప్షన్. రైట్? ఎఫిషియంట్ రీసోర్స్ యూటిలైజేషన్, కాస్ట్ ఎఫెక్టివ్. కాస్ట్ ఎఫెక్టివ్ డెఫినెట్లీ. సపరేట్ చేసే కానీ అన్ని వర్క్లు ఒకేసారి అయితే కాస్ట్ తగ్గిపోద్ది. అండ్ రిలయబిలిటీ. And here the failure of one processor does not always stop the entire system. Here 10 members చేసి బయట పెట్టేటప్పుడు ఇప్పుడు ఎవరో ఒకరు స్ట్రెయిన్ అయిపోయి బయటనే ఉన్నాడు అనుకోండి, దిట్ వర్క్ విల్ నాట్ బి స్టాప్. రిమైనింగ్ 9 members will continue. Right? So here is the same. Processor 1, processor 2, processor 3. Am I? Processor 1, 2, 3, 4 are actually there. They are executing task 1, 2, 3, 4. Unfortunately, task 3 is not executing because processor 3 is failed. No issue. These 3 will take care about that process. Once it is done, we'll execute task 3 by the processor 1, maybe. There is no disturbance. Now actually you want to discuss this distributed system. To discuss about distributed system, we should aware that serial computing and parallel computing. బాబు ఎవరికో హాయ్ చెప్తున్నావు కదా, అందుకే నేను కూడా చెప్తున్నాను. నాకు కదా. So, we want to discuss about distributed computing actually for your syllabus. To aware of directly going to a distribute, we should have this parallel and serial computing. Serial computing లో ఒకరే ప్రాసెసర్ ఉంటారు, ఒకరే అన్ని చేయాలి. ప్యారల్ కంప్యూటింగ్లో ప్రాసెసర్స్ 1 2 3 4 అండ్ మల్టిపుల్ ఉంటాయి, మల్టిపుల్ టాస్క్ ఒకటేసారి అయిపోతాయి. డిస్ట్రిబ్యూటెడ్ కంప్యూటింగ్ ఈజ్ అ కంప్యూటింగ్ మోడల్ ఇన్ విచ్ a single problem is divided into multiple smaller parts and executed across multiple independent computers connected through a network. Be careful here. As of now, single processing. Listen. ఇది అయిపోతే క్లాస్ చెప్తాను. పర్లేదు, మీరు అయిపోయాక వెయిట్ చేస్తాం. So serial computing law, we are saying that only one system. Say your laptop. ఒకటే ప్రాసెసర్ ఉంది. నువ్వు యూట్యూబ్ ఓపెన్ చేస్తే వర్డ్ ఓపెన్ చేయలేవు, వర్డ్ ఓపెన్ చేస్తే మీడియా ప్లేయర్ ఓపెన్ చేయలేవు, మీడియా ప్లేయర్ ఓపెన్ చేస్తే ఇంటర్నెట్ గూగుల్ క్రోమ్ ఓపెన్ చేయలేవు. దట్ ఈస్ సీరియల్ ప్రాసెసింగ్. ఒకటి తర్వాత చేయాలి. ప్యారలల్ కంప్యూటింగ్ వచ్చేసరికి యూ కెన్ డూ ఆల్ దిస్ టైమ్ ఎట్ ఎ సేమ్ విండో. గూగుల్ క్రోమ్ ఓపెన్ చేయి, యూట్యూబ్ ఓపెన్ చేయి అండ్ వర్డ్ డాక్యుమెంట్ డిఫరెంట్ విండోస్ కెన్ ఓపెన్ ఎట్ ది సేమ్ టైమ్. దట్ ఈస్ క్లియర్ అబౌట్ ప్యారలల్ కంప్యూటింగ్. అర్థమైందా? రైట్. All these two, serial and distributed parallel computing, with respect to only one system, one physical device, one personal computer. Now, whereas distributed computing is nothing but the task will be executed. Okay, one problem will be executed by the different machines. Your personal computer and her personal computer and his personal computer in other personal computer. And with respect to your personal computer, it may be a parallel computing process. All these are internally parallel computing. System 1, System 2, System 3, System 4 are collectively working for the one task. That is distributed. Same work cheyadaniki different type of independent systems. See here, across multiple independent computers connected through a network. And each independent computer may act as a parallel computing or serial computing. So mostly serial computing is vanished. Nowadays we are using all parallel computing only. Your personal computer, your friend personal computer and other computer and two more computers. All these four are connected in a LAN working for the same. What is the purpose to connect? To share a resource. నీ దగ్గర మీడియా ప్లేయర్ లేదు, యూ డోంట్ హ్యావ్. చాలా ఆవేశంగా ఉన్నారు ఇవాళ, ప్లీజ్ కంట్రోల్. సో హియర్ the distributed computing, independent computers are parallel computing connected in network to share the resources. నీకు కొన్ని సబ్జెక్ట్స్ వచ్చు, you four members are connected for example to discuss something. To discuss something is to discuss about tomorrow's exam. You know some units, somebody, three people also know some units. Then we have collected as a one group call to discuss and to share their knowledge. So I have thoroughly with the unit 1, but I don't know unit 2. Somebody else in my group may know the unit 2. So then I will share unit 2 about unit 2. I want to explain from other person. Then you are in perfect in unit 1, no? Definitely other three members may want about unit 1. Definitely you have to share your knowledge. Such that what happens that task will be finished very effectively. But it take independently, you can capable of read 1 2 3 4 units. But what happens that as of now only unit 1 is prepared and unit 2 is not able to get understand. మళ్ళీ అండర్స్టాండ్ చేసుకోవాలంటే ఇంకెక్కడో ఎక్కువసేపు టైం స్పెండ్ చేసి చదవాలి. ఇన్స్టెడ్ ఆఫ్ డూయింగ్ ఎక్స్ట్రా టైం, జస్ట్ ఐ వాంట్ టు డిస్కస్ హూ ఎవర్ ఇన్ ఎక్స్పర్ట్, వాళ్ళని కాంటాక్ట్ చేసేస్తాం గ్రూప్లో, వాళ్ళు షేర్ చేస్తే మనకి ఈజీ అయిపోతుంది. దెన్ టైమ్ సేఫ్ and easy to understand. So here also in the distributed computing, it is a model with single problem. Single problem is ఈ సబ్జెక్ట్ ఒకటి. and divided into multiple smaller parts are executed across multiple independent computers connected through a network. This is a basic definition. With this definition only, we would have to understand the distributed computing. Distributed computing. Or else, one more example, మీకు ఆర్ట్ డ్రాయింగ్ కాంపిటీషన్ ఉంది అనుకోండి, డ్రాయింగ్ ల్యాబ్ డ్రాయింగ్ యాక్టివిటీ ఉంది. We need, there is a theme is given to draw so and so theme and make it colorful. Definitely we'll purchase all the required materials, right? Unfortunately, you don't have some so and so color. Definitely all will have any different materials. Then we are expecting this green color, unnecessarily we don't have green color, we'll share this. And somebody else who don't have the blue color, we will share to them. Such that collectively, independently they have a capable of draw one theme. But here the resources are not available with your current position and you are not able to purchase again. Just for few seconds you can share it with the friends. That is distributed. Resources will be shareable to complete the only one task. Each node has its own processor. You have your own material, memory, and they communicate with each other by passing messages to coordinate the computation. Each person will have your own material to draw one theme, but will communicate through a channel, some mobile or messages or direct chat. So I need so and so. If it is not there, and independent computers, nothing but each component of the system can operate automatically. Independent four systems are connected in a network called as distributed. And if you consider as an independent computer, that is the capacity to do the work actually. Component of the system can operate autonomously. This independently, the computer, you itself, you can able to draw a diagram. But more effective for easily you are sharing. You itself has capability to read all 5 units. But for better understanding, for easy understanding, for due to the time constraint, I have called to somebody else, please explain unit 2 some glance. Then it is easy. So that is independently can also do the same task, but where distributed computing will be preferable to do the activity very fast and effectively. Collection, it is a group of these independent machines collected. And next one, before this, write down please. Definition, I will check the last one now. I'll repeat this, note down. Distributed computing is a computing model. ఇప్పుడు వచ్చి చెక్ చేస్తా ఈ సెంటెన్స్ లేకపోతే in which a single problem చదవాలి అక్కడ మీ నోట్స్లో ఏముందో చదవాలి రాస్తారా in a single system single problem or task is divided into multiple smaller parts or divided into multiple smaller parts and executed multiple smaller parts and executed across multiple independent computers across multiple independent computers connected through a network. each other by passing messages, communicate with each other by passing messages to coordinate the computation. To coordinate the computation. So these are the main components. Write down components of distributed computing. Components of distributed computing. Write down. Components of distributed computing. Normally, what are the distributed computing? Independent computers are connected through a network. That independent computing as a devices, as a one component, connected through a network. Next component and resource management. Every independent system will have a different kind of resources that should be maintained their own system, and as and when required by the other system can capable of sharing. Memory is a shareable or non-shareable? Is memory unit? Memory unit is a shareable or non-shareable? Yes or no? Shareable or non-shareable? Memory. You have a capacity of 1 terabytes of hard disk. Is it shareable to others or not? Can we share our 1 terabyte of memory space to other? Yes? Yes or no? You have 1 terabyte of empty space in your system and somebody else requesting 2 GB of data. So I have a 2 GB of data. So I want to load this my data into a system. Is it possible? Non-shareable. 2 GB only is accepting, which is free now. 1 terabyte complete free unnai. We can shareable that memory. Shareable device, shareable component is memory. As a printer, and a shareable is nothing but at a time more than one user can be used. No need data storage, other persons can also store their data. 2 GB need data, 2 GB other data. 4 GB, 1 terabyte of 4 GB use చేసుకోవచ్చు కదా. Whereas printers cannot be shareable because at a time only one user can take printout. నీ డాక్యుమెంట్ ప్రింట్ వచ్చేటప్పుడు వేరే డాక్యుమెంట్ ప్రింట్ రాదు. So that's what we cannot share it. So every user, every independent device will have a different kind of resources. Resources, memory, printer, keyboard, mouse, all these resources cannot be possible to share. Some can be shareable. The components are device by do. ఇది ఉండదా మిడ్ ఎగ్జామ్ ఏది ఉంటుంది ఆబ్జెక్ట్ ఇదంతా మల్టిపుల్ చాయిసా ఇంకేం సార్ కాలేజ్ వీళ్ళంతా ఉమెన్స్ కాలేజ్ వాళ్ళ వాళ్ళంతా ఉమెన్సా ఇప్పుడు పోయిన వాళ్ళంతా ఉమెన్స్ కాదు ఇప్పుడు ఉన్న వాళ్ళు ఉమెన్సా అందరు కలిసినారు ఇంకా అచ్చా డిఫరెంట్ స్టడీస్ ఉంటాయమ్మా ఇంకెవరు చెప్తారు మరి రైట్ డౌన్ మీరు కూడానా బ్రేకా ఎగ్జామా ఎగ్జామ్ పేరు చెప్పుకొని బ్రేక్ వస్తారా మళ్ళీ 11:25 12 వరకు వస్తారా సో నెక్స్ట్ దీస్ ఆర్ ద కాంపోనెంట్స్ అంటే డిస్ట్రిబ్యూటెడ్ కంప్యూటింగ్లో ఏమేమి కాంపోనెంట్స్ ఇన్వాల్వ్ అయ్యింటాయి ఇండిపెండెంట్ సిస్టమ్ కాల్డ్ ఎస్ డివైస్ అన్ని కనెక్ట్ కావాలంటే నెట్వర్క్ కావాలి. అండ్ ఎవ్రీ విల్ హ్యావ్ అన్ రీసోర్స్. అండ్ ఇంకా ఉన్నాయి. ఇది అయిపోయాక సిఓ సబ్జెక్ట్ అయిపోయిందా? కంప్యూటర్ ఆర్గనైజేషన్ సబ్జెక్ట్ ఉందా ఎవరికా? చదివారా? డిఎల్డి సిఓ ఉంటుందిగా మరి ఇట్లనా ఇట్లనా ఇట్లా సిఓ డిఎల్డి సిఓ ఉందా? చదివారు కదా? నువ్వు ఇక్కడ ఉన్న మ్యాటర్ చూసి భయపడద్దు. ద స్లైడ్ ఇన్ మీనింగ్ ఈస్ దట్ వాట్ ఆర్ ద కాంపోనెంట్స్ ఇన్వాల్వ్డ్ ఇన్ యువర్ డిస్ట్రిబ్యూటెడ్ కంప్యూటింగ్. Independent computer device. The device or system is distributed system have their own processing capability. లైక్ మీ నలుగురు డిస్కస్ చేసేటప్పుడు ఈ నలుగురు ఇండిపెండెంట్గా డివైజెస్. యూ హ్యావ్ యువర్ ఓన్ కెపాసిటీ టు రీడ్ 4 యూనిట్స్ ఆర్ 5 యూనిట్స్. దట్స్ వాట్ ఇట్స్ ఓన్ ప్రాసెసింగ్ కేపబిలిటీ టు స్టోర్ అండ్ మేనేజ్ దేర్ ఓన్ డేటా. మనకు ఉంది కెపాసిటీ 4 యూనిట్స్ అవే కెపాసిటీ. బట్ హౌ వీఆర్ ఇంటరాక్టింగ్ విత్ ద ఫ్రెండ్స్ ఎందుకు డిస్కస్ చేస్తాం? ఈజీ అయిపోవాలి, తొందరగా ఫాస్ట్ చదువుకోవాలంటేనే వీ హ్యావ్ కమ్యూనికేటింగ్. దట్ ఈస్ కాల్డ్ డిస్ట్రిబ్యూటెడ్. నెట్వర్క్ ఎట్లా కమ్యూనికేట్ అవ్వాలి? త్రూ సమ్ నెట్వర్క్. ద నెట్వర్క్ కనెక్ట్స్ ద డివైజెస్ ఆర్ సిస్టమ్స్ ఇన్ ద డిస్ట్రిబ్యూటెడ్ సిస్టమ్, allowing them to communicate and exchange the data. Like group call. Group call can be connected through a network, can exchange your information from one another to other. And resource management in distributed system often have some type of resource management system in place to allocate and manage shared resources such as computing power, storage and networking. I told you, you have different kind of resources. నీ దగ్గర కీబోర్డ్, మౌస్, సిపియు, ప్రాసెసర్, మెమరీ, ప్రింటర్, స్కానర్ నీ దగ్గర ఉన్నాయి. Somebody else, they also have almost the same, they don't have scanner. ఇంకొక పర్సన్ దగ్గర they don't have printer, scanner, they don't have. Somebody else will don't have that enough memory space. So itla resources ఉన్నాయి, but more or less not equal. You have 10 resources, somebody else 8, somebody else 2, somebody else 5. Then you are communicating. Whoever having 2 resources, they need more number of resources, they want more number of resources, then they will request other users. So I need printer, please give me some time. So I need scanner, please give me some time. I need a processor, please execute this program at your end. Right? So that is called resource management. So which is only possible resources only we can shareable. Printer ఒకేసారి new uses no అతను కూడా ఏమంటే it is not possible. That's what again of resource management system place allocate and manage shared resources only. Shareable resources only we can give in a distributed system such as power, storage, networking. Storage share చేయొచ్చు, power share చేయొచ్చు, network share చేయొచ్చు, but scanner, printer we cannot share. నార్మల్లీ ఎట్ ఎ టైమ్ షేర్ ఇన్ ద సెన్స్ డిస్ట్రిబ్యూటెడ్ సిస్టంలో ఇద్దరు ఒకేసారి యూజ్ చేసేటివి. యూ కెన్ షేర్ కంప్యూటర్ ప్రింటర్ బట్ వెన్ ఎవర్ ఇట్ ఈస్ ఐడియల్. నీ దగ్గర ప్రింటర్ లేదు, యూ హ్యావ్ కనెక్టెడ్ ఇంటర్నెట్ అండ్ టు దిస్ డివైస్ హ్యాస్ కనెక్టెడ్ విత్ ద ప్రింటర్. ఈ ప్రింటర్ని డివైస్ యూజ్ చేసుకోవచ్చు, బట్ ద ప్రింటర్ షుడ్ బి ఐడియల్, నో బడీ షుడ్ యూజ్. సో దట్స్ వాట్ ఈస్ నాట్ షేరబుల్. అంటే అయితే నువ్వే యూజ్ చేసుకోవాలి, అయితే ఈ డివైస్ యూజ్ చేసుకోవాలి, ఇంకొకరు యూజ్. ఎట్ ఏ టైమ్ ఓన్లీ వన్ యూజర్ కెన్ బి యూజ్ ద ప్రింటర్. దట్స్ వాట్ ఇట్ ఈస్ నాట్ షేరబుల్. బట్ విల్ హ్యావ్ ఏ చాయిస్ టు యూజ్ ఆల్ ద డివైజెస్. అన్నీ డిస్ట్రిబ్యూట్ చేయొచ్చు, ఈ రీసోర్స్ని డిస్ట్రిబ్యూట్ చేయొచ్చు, కానీ అందరికి మల్టిపుల్ యూజర్స్కి చేయలేము. I will listen this name, one human architecture. Do you have heard about this word one human architecture? అందుకే సిఓ సబ్జెక్ట్ ఉందా అని అడిగిన. డిఎల్డి సిఓలో కంప్యూటర్ ఆర్కిటెక్చర్లో వర్డ్ విల్లే వన్ హ్యూమన్ ఆర్కిటెక్చర్. డిఫరెంట్ కైండ్ ఆఫ్ కంప్యూటర్ ఆర్కిటెక్చర్స్ ఆర్ దేర్. డిఫరెంట్ కైండ్ ఆఫ్ కంప్యూటర్ ఆర్కిటెక్చర్స్ అంటే కంప్యూటర్ ఆర్కిటెక్చర్ అంటే హౌ ద సిస్టమ్ కంప్యూటర్ సిఓ సబ్జెక్ట్లో మనం నేర్చుకునేదంటే about internal structure of the computer. How devices are interconnected. Control F, what is it? Data saving. A data storage. One device is connected to other device. There is called a wires. ఇక్కడ వైర్లు అనొద్దు మనం. It is not like electrical wires. We can say it is a data from here to here. It is moving through the bus. అవన్నీ కంప్యూటర్ ఆర్గనైజేషన్లో చదువుకుంటాం. So that shows the different structure, organization of the computer system as a one architecture named as one human architecture. The one human architecture, the system can be compressed or collection of following components. The one human architecture comprises of four main components: memory, control unit, that is CPU, central processing unit, arithmetic logic unit, and input output. Basic structure ఇది. తర్వాత ఇంకా ఎక్స్ట్రా ఏమంటారు కంప్యూటర్ స్టైల్ మోడరేట్ మారిపోయినా కొద్ది చేంజ్ అయిపోయినాయి ఇంకా. దీస్ ఆర్ ద వన్ హ్యూమన్ ఆర్కిటెక్చర్. జస్ట్ వీ షుడ్ నో హౌ. ఇక్కడ ఏంటి మీకు ఫస్ట్, దిస్ ఈస్ నాట్ దేర్ ఇన్ యువర్ సిలబస్, but there is one more hardware distributed architecture is there. To understand the architecture of distributed system, first of all we should know what is the computer architecture. One of the architecture name is one human architecture. How the system will be. అసలు కంప్యూటర్ ఎట్లా కనెక్ట్ చేసినాము అంటే, దెర్ ఈస్ ఎ పర్సన్, వన్ హ్యూమన్ ఈస్ వన్ పర్సన్. ఈ సజెస్టెడ్ ఒక మెమరీ డివైస్ ఇండిపెండెంట్గా ఉంది, ఒక కంట్రోల్ యూనిట్ ప్రాసెస్ చేస్తే ఇండిపెండెంట్గా ఉంది, ఇన్పుట్ అవుట్పుట్ డివైస్ అన్నీ కలిపి ఒక అసెంబుల్ చేసి ఈ సైడ్ ఇట్ ఈస్ ఎ కంప్యూటర్. అన్నీ కలిపి ఈ సైడ్ ఇట్ ఈస్ అనే ఇన్పుట్ ఒక కంప్యూటర్ అన్నాడు. ఎలక్ట్రిక్ వెహికల్స్ వచ్చినాయి. బిఫోర్ దట్ వీ డోంట్ హ్యావ్ ఎలక్ట్రిక్ వెహికల్స్. ఇప్పుడు ఏం చేశారు, దెర్ ఈస్ ఎ బ్యాటరీ ఉంది. ఆ బ్యాటరీ ఉంది మనకి. ఇంతవరకు బ్యాటరీ యూజ్ ఏంటి, పవర్ పోతే ఇంట్లో బ్యాటరీ ఈ స్విచెస్ దట్ ఈస్ పవర్ పోతే ఇంట్లో ఆటోమేటిక్గా స్విచెస్ ఆన్ అయిపోతాయి, లైట్ ఆన్ అయిపోతాయి. ఏంటిదని ఇన్వర్టర్. ఇన్వర్టర్ ఉందా, ఇన్వర్టర్లో పవర్ ఎక్కడి నుంచి వస్తాయి, బ్యాటరీలో స్టోర్ అవుతుంది. పవర్ పోయినప్పుడు బ్యాటరీలో ఉన్న ఎనర్జీ కన్వర్టింగ్ ఇంటూ ఎలక్ట్రిక్ ఎనర్జీ అండ్ ఇట్ ఈస్ దేర్, ఇట్ ఈస్ స్టార్ట్ రన్నింగ్ ఫ్యాన్ అండ్ లైట్. అది బ్యాటరీ అంతవరకే యూజ్ చేసినాం. సేమ్ ఎలక్ట్రికల్ ఎనర్జీ యూజ్ చేసి టు మూవ్ ఎన్ ఏ వెహికల్. సో నౌ ఇన్వెన్షన్ హ్యాస్ బిన్ డన్. Already bike structure already is there. By using the structure, instead of running that bike by fuel, fuel also will be burned and converting into electrical energy. That electrical energy is helpful to move the vehicle. That is the basic logic actually. Some basic logic, instead of generating a electrical power by boiling this fuel, then he has suggested this is one battery which is having loaded with the electrical power and attached to this system with a instead of fuel, then it is converting into electrical vehicle. Just outline. So appudu vachina idea ne electrical vehicle structure. Adendi basic structure. Same year one human is given an architecture for a computer system initially. Oka memory device, input output devices and storage anni కలిపి connect చేస్తే assemble చేస్తే వచ్చిందే కంప్యూటర్. So note down here those devices, those components. Memory is used to store both the programs, instruction and data. The program instructions are coded data which tells the computer to do something. So here program instructions and data are two different. Program instructions and data are two different. Program instructions enti, we are giving an instruction every student while coming to the examination, follow this instruction. Don't bring electronic gadgets into the hall and bring your hall ticket, bring your ID card, right? Those are the instructions. Instructions are given to the students. We have written some instructions. Data is nothing but which is raw data which is already there. Data to compile a program, addition of two numbers. I have given the code, addition of two numbers. That code is by using Python. For example, 4 lines of code is there in Python, addition of two numbers. Not 4 lines, only 2 lines is enough. Right here, for example, 10 lines of code is there by using a Python for writing of addition of two numbers. That instructions that is called instructions. 10 lines or 4 lines. And data which is processing, addition of two numbers. 2 comma 4 as the data. 2 and 4 are the data which process 2 4 ఏం చేయాలి ఏం చేయాలి అని రాసిన 10 lines ఇన్స్ట్రక్షన్. అండ్ సి ప్రోగ్రామ్లో మ్యాట్రిక్స్ మల్టిప్లికేషన్, మ్యాట్రిక్స్ మల్టిప్లికేషన్లో మనం ప్రోగ్రామ్ రాస్తే అట్లీస్ట్ ఒక 2 పేపర్స్ వస్తుంది. ఆ 2 పేపర్స్ ఆఫ్ కోడ్ ఈజ్ కాల్డ్ ఇన్స్ట్రక్షన్. ఆ 2 పేపర్స్లో ఏముంటుంది? matrix A, matrix B values. You first ask what are the A values and B values of matrix. Matrix A values load చేయి, matrix B value load చేయి. Then take A and B values and apply multiplication in the such a way that first matrix of row 1, second matrix of column 1, such that apply in the multiplication, then produce in the result in the matrix structure only. దానికోసం లైన్ బై లైన్ ఇన్స్ట్రక్షన్ చెప్తాం. దోస్ ఆర్ కాల్డ్ ఇన్స్ట్రక్షన్స్. డేటా ఈస్ వీ నీడ్ టు గివ్ ద వాల్యూస్ ఆఫ్ మ్యాట్రిక్స్ ఏ కామా బి. మ్యాట్రిక్స్ ఏ మ్యాట్రిక్స్ బి వాల్యూస్ ఇవ్వాలి. సో హియర్ ఇన్స్ట్రక్షన్స్ అండ్ డేటా బోత్ ఆర్ డిఫరెంట్. ప్రోగ్రామ్ ఇన్స్ట్రక్షన్స్ ఆర్ కోడెడ్ డేటా, పైథాన్ కోడ్, జావా కోడ్, ఎనీథింగ్. కోడెడ్ డేటా విచ్ టెల్స్ ద కంప్యూటర్ టు వాట్, ఏం చేయాలో చెప్పేదే కంప్యూటర్కి, రైట్. అండ్ డేటా ఈజ్ సింపుల్ ఇన్ఫర్మేషన్ టు బి యూజ్డ్ బై ద ప్రోగ్రామ్. ఆ ప్రోగ్రామ్కి యూజ్ చేసుకోవాలి. అడిషన్ ఆఫ్ 2 మ్యాట్రిసెస్ అన్నప్పుడు మల్టిప్లికేషన్ ఆఫ్ 2 మ్యాట్రిక్స్ వాల్యూస్ ఇస్తాం కదా, దట్ ఈస్ కాల్డ్ డేటా, రైట్. The next component, control unit. It fetches the instruction or data from the memory and decodes the instructions and then sequentially coordinates operation to accomplish the programming task. The control unit ఏం చేస్తాం? You have supplied input data, 2 matrices values ఇచ్చేసాం. That will be stored in somewhere else in the memory. Then control unit fetch those instructions from the program, fetch the data from the memory and coordinate these two. ఈ డేటాని ఏం చేయాలో ఇన్స్ట్రక్షన్స్లో ఉన్నాయి కాబట్టి ఆ డేటాని ఇస్తే డేటా విల్ బి ప్రాసెస్డ్ బై ద కంట్రోల్ యూనిట్ అండ్ ఇట్ విల్ ప్రొడ్యూస్ ద ప్రోగ్రామ్ రిజల్ట్ యాజ్ ప్రోగ్రామింగ్ టాస్క్. ఏం చేయాలి? అర్థమెటిక్ యూనిట్ ఈజ్ అ వన్ కాంపోనెంట్. ఇట్ పర్ఫార్మ్స్ బేసిక్ అర్థమెటిక్ ఆపరేషన్స్. సో అర్థమెటిక్ యూనిట్ తర్వాత ఇంకా డిఫరెంట్ కైండ్ ఆఫ్ ఆపరేషన్స్ చేయడానికి ఆల్వేస్ వీఆర్ నాట్ కంప్యూటింగ్ అర్థమెటిక్ ఆపరేషన్ యువర్ కంప్యూటర్. Nowadays we are running in the big applications of complex problems analysis, data analysis and ML programs, AI programs. For that arithmetic logic unit is only not enough. So basically we need an arithmetic logic unit. It will perform basic operations. Whereas input output are the interfaces which interacting with the computer and human being. మనం ఇన్పుట్ డేటా ఇవ్వాలంటే ఒక కీబోర్డ్ కావాలి, మౌస్ కావాలి. To display, to know the output, there should be a monitor. Those are the input output devices. All these components are connected in a well structured manner, then it becomes a computer. That is suggested by the von Neumann. Then the architecture name is called basic architecture of the computer, von Neumann architecture. So now here parallel computing we have done, serial computing also done. Hardware architecture for the parallel processing. First of all, this von Neumann architecture, note down. This is the most important. Note down this von Neumann. వచ్చినాయి. మీకు డాట్ డౌన్ డిజైన్ అనాలిసిస్ పైన draw the diagram. Followed by this, memory is used to store both program instructions and data. Memory is used to store both program instructions and data. Programming instructions are coded data which tells the computer to do something. Unit, control unit as the next one. Fetches the instructions or data from memory, decodes the instructions, and then sequentially coordinates operations to accomplish a programming task. And last input output till the last input output. Arithmetic unit performs basic arithmetic operations, and the last one, input or output, is an interface to the human operator. So input or output devices only we can communicate with the system usually. Now the next topic, write down hardware architecture for parallel processing. Hardware architecture for parallel processing. Note down. First, note down the main part of parallel processing are CPUs. The main part of parallel processing are CPUs only. Parallel గా జరగాలంటే first number of CPUs ఉండాలి కదా. Main part of write down. The main part of parallel processing are CPUs based on based on how many instructions based on how many instructions and data stream based on how many instructions and data streams based on how many instructions and data streams can be processed can be processed at the same time. So here in the parallel processing అంటేనే మనతో పాటు ఇంకొకరు కూడా వర్క్ చేయాలి parallel గా. That depends upon the work. The work is categorized as a 4 different parts. And at a time అయిపోవాలంటే 4 works can take care by the 4 individual users. The only 2 works ఉన్నాయి అనుకోండి. 2 users are enough to do. Okay sir అయిపోవాలి. Task 1 by the user 1, task 2 by the user 2. 4 tasks ఉంటే user 1, user 2, user 3, user 4, all 4 members started at the same time. In 5 minutes or 10 minutes, they will be finishing off. It depends upon the based on how many instructions and data streams can be processed, that number of users can be decided. Same way, here also the CPUs or processors, CPU and a processor can be decided based upon your instructions and data. To run your YouTube, one processor is engaged to run your YouTube. To prepare a document, it is opened by one processor, one more processor required. Right? To surf the internet, Google Chrome and so on, Google search something, for that one processor is to work. Here you need three parallel tasks you have to do. I want to play videos, parallelly I want to surf the internet, and I want to prepare my resume in the Word document. So for these three, okay sir, okay system lo. But three individual processors should run. Any computer processor can do one task at moment of time. ఒకసారి ఒక వర్కే చేయగలదు ప్రాసెసర్. అందుకే నంబర్ ఆఫ్ ప్రాసెసర్స్ ఆక్టా కోర్ డ్యూయల్ కోర్ నుంచి ఆక్టా కోర్ ఎక్సా కోర్ ఈ ప్రాసెసర్ స్పీడ్ ఎక్కువ ఉంది అని మీనింగ్. ప్రాసెసర్ స్పీడ్ ఎక్కువ అంటే ఫాస్ట్గా చేస్తుందని కాదు. డిఫరెంట్ కైండ్ ఆఫ్ ప్రాసెసర్స్ ఆర్ ఎంగేజ్ ఫర్ ద డిఫరెంట్ యాక్టివిటీస్. ఒక్కొక్క ప్రాసెసర్ ఒక్కొక్క వర్క్ చేస్తుంది. సేమ్ టైంలోనే మనకేమనిపిస్తుంది, సేమ్ ఒకటే సిస్టంలో అన్ని రన్ అయిపోతున్నాయి, ఒకటే ప్రాసెసర్ అన్ని చేస్తున్నట్టు. నో, ఇంటర్నల్లీ ఒక ప్రాసెసర్ కాదు, దట్ ఈస్ మల్టిపుల్ ప్రాసెసర్ విల్ డూ మల్టిపుల్ టాస్క్ ఇన్ ప్యారలల్లీ. అందుకే మనకు ఫాస్ట్ జరిగిపోయినట్టు అయిపోతుంది. అంతేగాని ఒకటే ప్రాసెసర్ వీడియో ప్లే చేసి, ఒకటే ప్రాసెసర్ డాక్యుమెంట్ ఓపెన్ చేసి, ఒకటే ప్రాసెసర్ ఇంటర్నెట్ సర్ఫింగ్ కాదు, మల్టిపుల్ ప్రాసెసర్స్. దట్స్ వాట్ ద కోర్ నంబర్ ఆఫ్ కోర్స్ ఆర్ ఇంక్రీస్డ్, దెన్ యువర్ స్పీడ్ ఆఫ్ యువర్ కంప్యూటర్ విల్ బి మోర్. So that is the main role of the parallel computing. Here the computer system, next write down. Computer systems are grouped into four types of computers. Computer systems are, write down. Computer systems are grouped into four types. Grouped into four types. Number one, single instruction, single instruction, single data systems. In bracket write down SISD. Most important topic. Single instruction, single data systems, SISD. How write down? First one, single instruction, single data system, SISD system. Single instruction, single data system. In bracket, SISD. Second one, single instruction, multi data system. That is multiple, multis are multiple. Single instruction, multiple data system. Single instruction, multiple data system, that is SIMD. SIMD. Single instruction, multiple, single instruction, multiple data system, SIMD. Number three, write down. Instruction, single data system, multiple instruction, single data system, multiple system, single data system, MISD. MISD. Last fourth one, multiple instructions, multiple data systems, multiple instructions, multiple data instructions, MIMD. Multiple instructions, multiple data systems, MIMD. These are the four different kind of systems exist in a run with the concept of parallel processing. Parallel processing law, these are the four different computer systems. This computing architecture, parallel computing architecture law, we have combined these four types of systems. These four types of systems are embedded into a one single system, then it will be acting as a parallel computing. That system will have a property as parallel computing. Single instruction, single data చేస్తుంది. Single instruction, multiple data అని కూడా చేస్తుంది. Multiple instruction, single data. Multiple instruction, multiple data. These are the capabilities of a parallel computing which are embedded into that. So ఏదైనా parallel computing లో system, nowadays all are parallel computing. Parallel computing architecture ఏంటంటే these are the different kind of architectures we have. లోపల హార్డ్వేర్ ఎలా ఉంటుంది? సో కనిపిస్తుందా లాస్ట్ వన్? వాట్ ఈస్ దిస్? కనపడలే? Note on this diagram. This is instruction stream. This is data input, and it is processor and data output. First of all, note down this diagram. This is a type of system, single instruction, single data system. Single instruction, single data system. Note down. Run. Note down the diagram. Single instruction from the top, from the left side, single data. The right side shows output. So here, first system, this is architecture of the single instruction, single data system. Hope everyone noted. Most important, these four types of systems. అయిపోయిందా చూపించండి ఒకసారి అయిపోయిందా నోట్స్లో వాట్సాప్లోనే ఉన్నాం ఇంకా ఫస్ట్ బెంచ్ రాయాము లాస్ట్ బెంచ్లో రాయాము కనపడినంత కనపడుతుంది సంథింగ్ యువర్ థింకింగ్ అంటే అయిపోయినట్టున్నా మీ ఇంటికి పోయినావా డయాగ్రామ్ డ్రా చేయను చెప్తా నోట్ ఉంది డయాగ్రామ్ రైట్ రైట్ ఆన్ this is a diagram shows that on top of this diagram silence first bench hey Samay hello single instruction single data in system write down SISD computing systems SISD computing system is a uniprocessor SISD computer system is a uniprocessor system write down phone పక్కన పెట్టాలి SISD computing system is a uniprocessor system capable of executing sentence everybody should write చాలాసార్లు చెప్పిన I request to write a note అని రిక్వెస్ట్ చేయమని SISD computing system is a uniprocessor system which is capable of executing which is capable of executing which is capable of executing a single instruction which is capable of executing a single instruction single instruction which operates on a single data stream, which operates on a single data stream, which operates on a single data stream. So here, see the diagram. This is a processor. See, first of all, SI is the system structure. The processor will do the process. That is, whatever the instructions, మీరు ఏదైతే ప్రోగ్రామ్లో రాశారో addition of two numbers, ఆ ఇన్స్ట్రక్షన్ ప్రకారం it is asking what are the numbers you want to addition. ప్రోగ్రామ్ మనల్ని అడుగుతుంది కదా, ఆ ప్రోగ్రామ్ అడిగేది డేటా. నువ్వు రాసిన సి ప్రోగ్రామింగ్, పైథాన్ ప్రోగ్రామింగ్, జావా కోడ్ ఇన్స్ట్రక్షన్స్ are called programmed instructions. So these are the instructions are the programmed instructions. Let's say this instruction is single instruction. Single instruction is nothing but single program, not one line. One program, C program. A program and addition of two numbers. This is one single instruction stream. Stream of instruction and a collection of instructions. Those collection of instruction I can say one program. The program aim is to write addition of two numbers. Addition of two numbers C lo rasa oka 5-10 lines program anukondi. That is called one instruction. This stream of instructions ikkada processor ki istam. A stream of instruction lo em rasam? First input, take the input values. After taking the input values, nee memory lo ekkada store ayi, then scanf tarvata and read the inputs from the data. అప్పుడు మళ్ళీ ఆ మెమరీలో ఉన్న ఇన్పుట్స్ని తీసుకో, అడిషన్ చేసేవారు రెండింటి మధ్యలో. Do addition operation by predefined function operator place operator, that is C is equals to A plus B అనే స్టేట్మెంట్ ఎప్పుడైతే ఎన్కౌంటర్ అవుతో that will be executed as it takes the values of A comma B from the memory and complete addition operation between these two. Result will be stored in a variable of C. C ఎక్కడ ఉంటుంది? C will be already defined in the memory. C కి ఒక స్పేస్ ఉంది, C కి ఒక చైర్ ఉంది, ఆ C లో రిజల్ట్ పెట్టేశారు. This whole process will be done by this processor. అంటే A comma B values, enter A comma B values అనగానే 2 comma 3 ఇచ్చామనుకోండి. First of all, before going to this, you have an instruction int A comma B comma C. Whenever a program executed a line int A comma B comma C, meaning ఏంటంటే సిస్టమ్కి we are asking that I need A comma B comma C 3 variables. For 3 variablesకి memory కావాలి, 3 chairs కావాలి in your computer memory of integer అన్నాం. Integer occupies 4 bytes of memory. ఒక్కొక్క దానికి 4 that is 4 or 2. 2 is an older processor, now it is 32-bit processor, now it is 64-bit. 64 లో 4, right? Sir, otherwise you write 2 comma 4 bits. ఒక్కొక్క వేరియబుల్ కి ఇంత స్పేస్ కావాలి, it is allocated 3 seats. Then you have given A comma B values. What is A and B? ఎప్పుడైతే A comma B values yes, ఎప్పుడైతే A comma B values ఇచ్చామో 2 comma 3, that will be loaded. A ఎక్కడ ఉంటే అక్కడ A పెట్టాలి, 2 పెట్టాలి, B ఎక్కడ ఉంటే అక్కడ 3 పెట్టాలి. Now it is loading, getting the information or fetching the information and loading into the memory done by this processor. Once there is a statement encounters C is equals to A plus B, we don't know what is A and B. Then again computer or operating system fetch what is A and 2. Come, take it as 2 value. What is B? Take it as 3 value. Perform 2 plus 3. Perform 2 plus 3. So that 2 plus 3 is the 5 value will be loaded C. But what is C actually? C, there is a one empty space is there, that 5 will be loaded in C. All this process will be done by this processor. Then finally you return a statement printf C is equal to so and so percentage D. Then one data output will be coming out. On the output screen, the value C is equals to 5 will be displayed. Or addition of the given two numbers is 5, it is displayed. Single instruction, single data. Single instructions and single data. And here this processor, and this processor is uniprocessor, ఒకరే processor ఉంటుంది.
and remaining SIMD, MISD, MIMD is the different. ఇక్కడ ఒకటే ప్రాసెసర్ అన్ని వర్క్స్ చేయాలి. దట్ ఈస్ లైక్ సీరియల్ ప్రాసెసింగ్ లాగా. సీరియల్ ప్రాసెసింగ్ లాగా ఉంటుంది ఎస్ఐఎస్డిలో. ఒక ప్రాసెసరే అన్ని పనులు చేయాలి. దట్ ఈస్ ఓన్లీ వన్ ప్రాసెసర్ విల్ డూ దట్. హియర్ ఇన్స్ట్రక్షన్ తీసుకోవాలి, డేటా తీసుకోవాలి, అకార్డింగ్ టు దట్ ఇట్ విల్ ప్రాసెస్, మిక్సప్ సంథింగ్ టు అండ్ ప్రొడ్యూస్ అన్ అవుట్. Note down in the single instruction point, one more point note down. Single instruction SISD systems are the simplest and most SISD, write down. SISD systems are the simplest and most traditional types of computer architecture. SISD systems are simplest and more traditionally computer architectures. Traditional architectures, traditional architectures, where one processor executes one instruction, one processor executes one instruction, one processor executes one instruction on a single data stream, on a single data stream at a time, on a single data stream at a time, on a single data stream at a time. Next point. Next point. SISD systems. In SISD systems, in SISD systems, instructions are processed in sequential manner. Instructions are processed in sequential manner. Sequential manner. That is like you are reading your textbook or notebook. One by one, like paper by paper, page by page, line by line you are reading. No, the system also it is working in the same way. It is like process a person reading and solving math problem one by one without skipping any. First problem, second one, and so on. And each problem you are doing in a step by step. As slow. This model follows the conventional and von Neumann architecture. Yes, we have discussed the von Neumann architecture as before SISD, MISD, SSID. So von Neumann architecture, normally there is a one processor and arithmetic logic unit and so on. It takes instruction and execute it. Take the instruction, execute it. Which a single control unit fetches instruction from the memory, processor, data by step by step. So examples are no doubt like IBM mainframe computers. In 1966, mainframe computers are there. Mainframe computers following this SISD architecture. SISD architecture. IBM mainframe computers. Examples are IBM PCs, Macintosh computers, and regular workstations use this system. That is olden days we are using. Nowadays it is not SISD. It has been changing.